X equals 4 plus or minus 2I square root of 2 all over 6. And now here you can reduce that. You can divide everything by 2. So X would be 2 plus or minus 1I square root of 2 over 3. Okay? Again, if you want to put them both over 3, you can. 2/3 plus or minus I square root of 2 over 3. Be another way to look at that. Alright, graphs of quadratics. We did a whole unit on quadratics. Now we're going to be just zoning in on their graphs today. The first couple of notes that we're going to make are the different, we don't want any of that, are the different forms that our quadratics can be in. We've worked a lot already with standard form. F of x equals ax squared plus bx plus c. We call that standard form of a quadratic. When our equation is in standard form, we're going to start zoning in on these graphs. We're going to be talking about vertexes, axis of symmetry, all that kind of stuff. There is a shortcut to use to get your x of your vertex. You do the opposite of your b divided by 2a. Negative b divided by 2a will tell you the x of your vertex. Okay? Negative b divided by 2a. That's going to be pretty huge. Okay? When we're in standard form, so when the equation shows up there, it's just negative b over 2a. We're in standard form. When we have standard form, we got to use that equation to start finding our vertex. Now that only finds the x. Remember, a vertex is an x comma y. So that equation only finds the x. What would you do to get the y? Plug it back in. That's exactly right, Sir Rutledge. So everybody good on standard form?
Yes.
Okay, good, Sir Ferguson. Other one that we have is vertex form. Okay, I've already lost connection in 5 minutes. Let me try one time and then I'll just go to the board. So there's vertex form. Let's see if it'll. Connect up in here, so I'll see. Vertex form, we got f of x equals a times x minus h squared plus k. And it's called vertex form for the very reason that it tells you what the vertex is. Anytime it's written in vertex form, it's like a flashing neon sign. Here's your vertex, here's your vertex, here's your vertex. You get the vertex from your h and your k. Alright, now notice in the form it says minus h. Here I just wrote h. That's key. The x part of the vertex, the h is always the opposite sign. When you're in vertex form, the x is the opposite sign. The k, it just is what it is. X is opposite, y is what it is. H is opposite, k is what it is. Okay? So we didn't have to have a formula. Standard form, we needed a formula. Vertex form, you don't need one because it's called vertex form because it tells you the vertex. Alright? Got those down, ready to do some graphing and use this stuff? Yes, 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 yes. This says f of x equals x squared plus 3. Alright, we're going to cover 5 things with this. We're going to graph it, uno. We're going to tell the vertex, dos. We're going to tell the axis of symmetry, trace. We're going to tell the domain, quattro, And we're going to tell the range. 5. Okay, all 5 things will be covered on this. So first off, before I start figuring out the vertex, I got to decide what form that's in. I just gave you 2 choices. Is that in standard form or vertex form? Very good, Grace. It's in standard form. And I had a kid come in at lunch and told me he didn't understand how I knew if it was in standard or vertex. Easiest thing, vertex has something in a parenthesis, standard doesn't. That's your flashing sign for you on that. So there's no parentheses here, so it is standard form, which means I've got to use that new little formula you just wrote down, which means I got to know what my B and my A are. What's the B if that's in standard form? 0. What's my A? 1. We know from quadratic formula the C is a 3, but that doesn't matter in this. All I need is my A and my B. Now, anytime the B is 0, a lot of y'all can skip some steps, but I'm going to go ahead and show my work for the rest of us. X is negative B divided by 2A. Here's why a lot of y'all can skip steps. If your B is 0, 0 divided by anything is 0. So my X is 0. Okay? Now remember I told you on vertex you need an X and a Y. We don't have anything in that Y spot. Chase said we needed to take our 0 and plug it in. So Y would equal 0 squared plus 3, which means Y is
3.
So the vertex for this parabola goes over 0 up 3. Alright, now that was one of the 5 vertex. Another one I said was axis of symmetry. Would you believe we already know the axis of symmetry? Remember what a parabola, not just a side note, a parabolas are U-shaped. The vertex is at the very center, which means your axis of symmetry has to go through the vertex, right? If I'm going to be able to fold that. So this line that my vertex is on is my axis of symmetry. So I already know my axis of symmetry. I just got to know how to write it. From the origin, I didn't move left or right any. The axis of symmetry is always the x of your vertex. When you did this work, you got your axis of symmetry. Okay? Axis of symmetry and vertex go together. They're holding hands in the back of the movies. Okay? They go together that way. All right? We good on that?
So they're the same thing?
The x part of the vertex. Yes. All right. Now, I've got axis of symmetry. I've got vertex. We got to graph it. Cool thing is, y'all know when we graph a lot of times in here, I make an X. I do this, and I make y'all pick like 3 or 4 of these here. I only got to pick one. Why am I only going to have to pick one?
You just flip it.
Very good. Already got one, and then wherever this other one winds up, like Kaylee said, I just put it in the opposite spot on the other side because that axis of symmetry's got to be in the middle. It's got to fold and meet it. So pick me any X except for 0. You can't use 0 because you already know it.
1.
So 1. So if I did 1, 1 squared is 1 plus 3 is 4. So I'll go over 1, up 4. Okay? Now it's good old kindergarten counting. This point is 1 away from the axis of symmetry, so it goes 1 away on the other side. Shazam! There's your parabola. Axis of symmetry, check. Vertex, check. Graph, check. We got 2 more. Domain and range. I'm going to say D and R for domain and range. Remember, domain is your x's. Yeah. Left and right. Is this thing ever going to stop reaching to the right?
No.
No. Is it ever going to stop the left? No. So Zane's correct. It goes from negative infinity to infinity. Also known as
all real numbers.
All real numbers would be another way. Good job. Okay. Range. Y's up, down. Is this ever going to stop going up? No. But is it ever going to stop going down?
Yes.
Yeah. Good. It goes down to the Y of your vertex, which Chase said is 3. Yeah. So my range goes from, it touches 3, so it gets a bracket, 3 to infinity. Good job. There's another way I could write it if I wanted to. Y has to be greater than or equal to 3, doesn't it? Either one of those would be fantastic.
Yeah.
Woo! Graph, check. Vertex, check. Axis symmetry, check. Domain, check. Range, check. Masons in kindergarten, check. Oh, just kidding. Sorry, he was tracing things with John Wayne over here. That's what it made me think of. Okay. We good? Alright, let's look at another. Wish you had magic graph paper, Grace.
I wish I could.
At one point I had and I still probably got it somewhere, I just don't know where it is, but I had a stamp, about like that, and I could stamp your paper and then have graph paper. But people would grab because it was too small. Well,
Probably the same size as my pinky graph.
yeah, I mean, it'd be bigger than a graph you would draw on your paper, but
Whoa. Whoa.
let's do that one. That's too small. Alright, we got the same 5 things to check off our list. Vertex, axis symmetry, graph, domain, range. F of x equals x minus 2 squared plus 1. Before I name any of those 5 things, is this function in standard form or vertex form? Vertex, we got a parentheses. Vertex makes your work easier. It tells you the vertex. What is it telling me my vertex is?
2, 1.
2, 1. Remember the x is always the opposite sign. Was a negative 2, so we took a positive 2. Y gets the sign right. It is what it is. Okay, so the vertex, it goes over 2 and up 1. That also tells you your axis of symmetry. X equals what is your axis of symmetry?
2, 1, 4.
Chase had it.
-2.
It's the x of the vertex, right? Because it's got to be in the middle on that. And now I didn't talk about this on the last one, but let's use some common sense and think about it. Normal parabolas. We're talking normal ones now. We'll get to the special ones later. Normal parabolas can open up, with their arrows going up forever, or they can go down. Their arrows going down forever. I wonder which one this one's going to be. Last one was an up. Grace thinks this one's the same. It's going to be an up. And Rachel concurs, and y'all are correct. It comes from the A. If your A is positive, it opens up. If your A is negative, it opens down. There's no number in that A spot, so it's understood 1, which means it opens up. Okay, reason I want to talk about that, if I pick some point and plug it in, and it ends up down here from my vertex, I'll know I've screwed up, right? This thing's going to open up. My other point's got to be up here somewhere, right? Okay, so I can pick any x I want to plug in now, except for 2, because I already got 2. So how about my fave, 0. Let's plug a 0 in that thing. Can we do this mentally here? 0 minus 2 is -2. Square that and you get 4. Add 1 to that and you get 5. Over 0, up 1, 2, 3, 4, 5. That makes sense because I know it's got to open up. Good old counting here. That is 1, 2 away from the axis of symmetry. So you flip it and go 2 away on the other side. You have the best looking parabola
in the county.
In the county. Domain. What do we think?
Negative to positive.
Negative infinity to positive infinity. But that's the same as the last one. Zane's right what he just said. If it's a normal parabola with your ends going up or your ends going down, the domain is going to be this every single time. When we get to those funny ones where we're sideways later, it'll be different. Go ahead, Zane.
Will you ever get one that doesn't keep on going? It stops?
When we get to the sideways ones. Only then. But for these, like this, Zane's right every time. Okay, now, range. What are you going to write for range?
1 to infinity.
Bracket
1 with a
bracket
to infinity. So what Zane was asking about later, I don't know if it'll be the end of this week or next week when we start doing the sideways parabolas, these switch, Zane. It'll be the range that'll go infinity and negative infinity. Alright, did we get 5 things? Graph, check, vertex, check, axis, symmetry, check, domain, check, range, check. Not to that. But I just smile. Teach my little math problems. Hey Dustin, did you have a nice nap? Good morning, sunshine!
You know you have great focus on.
Thank you. Woo! Fx equals negative 2x squared minus 3. Well, what kind of form is that in? Vertex or standard? Standard, which means I need to at least know my A and my B. You know your C from last unit, but don't need it for the vertex. What's my A? Negative 2. Oh, negative.
It's going to open down.
It is, Michael. It's going to open down. Nice job. What's my B? 0. So, what's my axis of symmetry? 0. Because you do 0 divided by anything, you get 0. What is the rest of my vertex? 0, comma what? Oh, that was slow. Good, Grace. Here's the fast way. Good job, Grace. If I plug a 0 in here, squaring a 0 and multiplying something by 0 is just 0. It just takes it out. All that'd be left there's a negative 3. Alright, so we go over 0, down 3. 1, 2, 3. That's also our axis of symmetry. But Michael told me that opened down. I better scoop my paper so I get some down paper there, huh? Alright. I can't use 0 to plug it in. I already got it, so... Okay, Grace is going to do a 1. I'm with her there. I plug a 1 in. 1 squared is 1. Times negative 2 is negative 2. What's negative 2 minus 3? Negative 5. Let's find that point on our graph. Right 1, down 5. 1, 2, I can't count. 1, 2, 3, 4, 5. Flip that thing on the other side of the axis of symmetry. 1, 1. Best looking parabola in the county is same with proclaim. What's the domain? Same as it's been. What's the domain? Negative infinity to infinity. Let me write it just so we can get it written. What about good old range this time? Close. Atta kid. Negative infinity, because we always go the lowest first, right? And then the highest it gets is negative 3. Good job. So those got, the infinity got put in another spot this time because it was negative infinity, right? Yes. Whoop, whoop. Whoop, 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 whoop. I got one more. Can you stomach one more? Yes, you can. Got one need there? Whoa. Said to do that. Why didn't it do that? Just me when I'm talking to you. Yeah, that's the one. Woo-hoo! F of x equals 1/2 times x minus 2 squared plus 1. What's new in this one?
We have an A of 1/2.
Good. We got an a of 1/2. We got a fraction out there. Now, that a is a positive 1/2, so it's still going to open up. But what does that tell me about it? Anybody remember back to good old Algebra 2 days what a 1/2 out in front is going to make the graph look like?
It's wider.
Very, hey, yeah, kid GT. It's going to be fat wider. I sometimes say fatter. If it's a fraction, if it's less than 1 out in front, it gets wider. If it's bigger than 1, it gets more narrow. So this one's, it's not going to be a ton wider because it's a half, but it is going to be a little bit wider. All right, did you tell me what form it was in and I forgot? What form is that in? Vertex. So what is the vertex?
A positive 2 and 1.
Good job, Miss Rachel. 1, 2, 1. What's the axis of symmetry?
X equals 2.
Good job, good job. Look at there. Pick me a point that we don't already have. 3. 3 minus 2 is 1. Let me write down what I'm doing so I don't forget it. 1 squared is 1. Times a half is a half. And a half plus 1 is 1 and a half. Or you could write 3 halves. I was thinking 3 halves and I put a 3. Stupid. Stupid, stupid. 1 and a half. Bless you. 3, 1 and a half. It's easy for me to do halves because I got fancy graphic paper up here. Okay?
Yeah.
Flip that on the other side. Bam, bam. Missed that one. That looks pretty good. Does that look a little wider than the last one I drew? Not humongo wider, but it is a little bit spread out, a little bit wider on that. Domain, it's the same. What is it fast? No. Did you get that? Negative infinity to infinity. What about range?
1 to infinity.
1 to infinity and beyond. Good job. Good review there on some characteristics of some quadratics. Okay, this is what you're going to answer for me.
We're doing the exact same stuff in trig right now. We started it today.
That's funny. Alright, appearing momentarily. 6th period. I always get nervous on pep rally days and think I gotta hurry, and now we got a lot of extra time. Oh well, no. Sorry, it's probably 2, 6, 18, 6. Push you. Alright, it's there, it's there.